Permutation means the arrangement, like the food menu, and combination means what you are going to select. The total number of operations can be written in the form of m plus n ways. So factorial is nothing but the product of first n natural numbers. Hello my dear students, a warm welcome to one and all. Today in this session, I'll be introducing to the second chapter in the unit algebra, that is permutations and combinations. Okay, so before going to permutations and combination, okay, so let me see what are the concepts you will be learning in this session. Okay, so the first thing is introduction. So let me introduce to you about permutations and combinations. Next, fundamental principle of counting. Okay, so to study about permutations and combination, you need the basic concepts of fundamental principle of counting, then factorial. Then we'll be studying about what is permutation and what types of permutations we will be learning in this session. Next, a formula for permutation and very simple problems that we will use or solve using the formula of permutation. Okay, so now let us start about permutations and combinations. Okay, so here we have an introduction. So what do you mean by permutation and combination? Let me take an example. Okay, so we will go for a restaurant. Okay, obviously we'll go for a restaurant to eat or drink, anything like that. So you will have a food menu, correct? So there the food menu will be arranged already like North Indian dishes, South Indian dishes, salads, starters, juices, ice creams, like that. Okay, but what you will do? You will be ordering everything? No. So you will choose your favorite food, correct? So permutations and combinations are like that. Okay. Permutation means the arrangement, like the food menu, and combination means what you are going to select. Okay, so therefore we can say that permutations and combination are the ways to represent a group of objects or digits or letters. Okay, next, these are the methods used to find how many outcomes are possible. Okay, how many outcomes or possibles are nothing but how many elements we can choose or how many ways we can write those elements. Okay, so therefore we can say permutation is an arrangement of objects, whereas combination is nothing but selection of objects, like the food menu and the food you are going to choose. So food menu is permutation and the food you are going to choose is combination. Okay, so next is, I'll give you an example. My fruit salad is a combination of bananas, apples and grapes. Whether you put apple, grapes, banana or banana, apple, so there is no change at all. So this is an example for combination. Okay. So here we are only going to choose the things. We are not going to arrange it. Oh, first let me put apple, then banana, then grapes, then pomegranate, like that. No, we will arrange it or we will choose to put anything to make a fruit salad. Okay. So that is an example for combination. So this is a combination. Okay. So next, I'm going to take an example, that is the combination of a safe lock is 298. So what do you think? Is it a permutation or combination? Yes. For example, your mobile phone, you keep a secret password. Like for example, 1991 you have chosen. Okay. Suppose if you put 1992, your password, no, the mobile will not open. So you have arranged this already. Okay, so you cannot change the arrangement here, or you cannot choose any number like 928, okay, or you put 829. You cannot rearrange them. Okay, so that is permutation. So this is an example for permutation. Okay, so next I am taking an example like letter X, Y, Z. Okay, I have to arrange it in a two variations, like for example XY, YZ and ZX. Okay, I can choose any two letters from XYZ and I have to arrange the two letters at a time. I am arranging two letters at a time. So therefore, I'm just arranging, okay, but this can be arranged in different manner also. Suppose xy can be written as yx also, yz can be written as zy also, and zx can be written as xz also. Okay, so this is nothing but arrangement. Okay, so this is nothing but arrangement, that is permutation. So however you choose any two letters, this is combination. You have to arrange it in different way, this is permutation. So choosing the things are nothing but combination, arranging the things are nothing but permutations. Okay, so I have taken few examples here. So let me identify what are those permutations and combination. For example, selection of food in a menu. I already said it is a combination. You can choose any food of your favorite. Okay. So next, selection of subjects in class 11. Okay. That is up to you. You can choose either science or commerce. In science and commerce also you can choose PCMB, PCMCS, ECBA, SEBA, like that. You can choose many types of subject. This is also an example for combination. Okay. So next, placing first three winners in an athletics. Okay, you have to place first three winners. So there the arrangement matters, the order matters. Okay, first place, second place, third place. Okay, so therefore this is an example for permutations. Okay, so picking three members from a group among 10 members. You can choose any 3 members from 10 members. Okay, so there is no restriction whom you have to choose. Okay, so therefore this is an example for combination. Okay, arranging books in a library. What do you think? It's a combination. Can you put any books under any shelf everywhere? No. A library is nothing but arrangement. Okay, so all the subjects are arranged in different shelves, right? So therefore arrangement matters in library. That is, order of the books matters. Okay, so therefore this is an example for permutations. Okay, so now I think you know what do you mean by permutations and combinations. Okay, so permutation means arrangement of things, combination means selection of things. Okay, so whereas in permutation, order of the things matters. In combination, order doesn't matter. Okay, you can choose in any way. Okay, so this is the difference I have given. As I already said, permutation is the number of ways to arrange things. Order matters, and this is for lists. Okay, we can form a list. Lists are in ordered way always. Okay, so combination means number of ways to choose things. Order doesn't matter. This is all for groups. Okay, we can form many types of groups. Okay, so here the order doesn't matter. So this is about permutations and combinations. Okay, so now as I said, before going to learning about permutations and combinations, we have to know two important concepts. That is, one is fundamental principle of counting. Fundamental principle of counting. So here we have two rules. Okay, so that first one is sum rule and second one is product rule. Okay, so what do you mean by sum rule and product rule? Okay, suppose I take two objects or types of objects. Okay, so when m number of elements are arranged in other ways and n number of elements are arranged in different ways. Like for example, if one operation can be performed in m different ways and n operation can be performed in other different ways, but they are mutually exclusive. Okay, so what do you mean by mutually exclusive? Okay, so mutually exclusive means happening of one thing does not disturb the happening of the other. Okay, so then m different ways of one thing and n different ways of the other thing, then the total number of operations can be written in the form of m plus n ways. Okay, so let me take an example for this. You can see here in how many ways you can choose a number from 1 to 20, which is a multiple of 5 and 7. Okay, you have a number from 1 to 20, right? So 1, 2, 3, etc. 20. Okay, now you have to choose the multiple of 5 as well as the multiple of 7. Okay, so let me choose the multiple of 5. What are the multiples of 5 from 1 to 20? 5, 10, 15 and 20. So these are the multiples of 5. So how many elements you have in that set? That is 4. Okay, so other than anything you have? No, 5, 10, 15 and 20 are the multiples of 5 from 1 to 20. Okay, so multiples of 7. So what are the multiples of 7? 7 and 14. So how many elements you have? 2 elements. Okay, so therefore total number of choosing a number. So how many elements of 5, multiples of 5 you have? 4. How many elements of multiples of 7 you have? That is 2. So therefore the total number will be 6. Okay. So therefore, if 5 is 4 and 7 is 2, then this can be written as m plus n ways, that is 4 plus 2, that is equal to 6 ways. Okay, so this is about the sum rule and fundamental principle of counting. Okay, so the next one is the product rule. Okay, so what does the product rule says? So as I said, the sum rule is m arrangements are going or differently happen for n arrangement. They will not disturb each other. Okay, they will not occur simultaneously. Okay, whereas here, suppose when they occur simultaneously, what happens? Then we use product rule. Okay, so that is m ways of operations can be performed and n ways of operations can be performed. Then the simultaneously, when they occur simultaneously, the number of operation can be performed in mn ways, that is m into n ways. Okay, so let me take an example for this. A die is cast and a coin is tossed. Okay, you know what is dice, you know that is from 1 to, you will play a Ludo game and all. So dice. Okay, so what are the outputs you will get? That is 1 to 6, that is 1, 2, 3, 4, 5, 6. Okay, you will have a Ludo like this. So here you will be having 1 dot, 2 dot, 3 dot. Okay, so when you cast a die, you may get the output from 1 to 6. So how many elements we have here? Totally 6. When you toss a coin, what happens? Either you will get head or you will get a tail. So how can I write this in the form? So it will be like this. Okay, it will be like this. Suppose if you get 1, you can get head. Suppose if you get 1, you can get tail. This is one ordered way. Suppose when you cast a die, you get 2, then you may get head with 2, then you may get tail with 2. So similarly, okay, so for 6 also you may get head and for 6 you may get tails. So how many operations we are going to do here? For each number, you have 2 different elements with that, either head or tail. So therefore, there will be total 12 outcomes. Okay, there will be total of 12 outcomes possible. So this is what fundamental principle of counting of product rule. Okay, so in sum rule, the occurrence of 2 operations do not disturb each other. Okay, whereas in product rule, they occur simultaneously. Therefore, in sum rule, we take it as m plus n, and in product rule, we take it as m into n. Okay, so now let me start one more thing, that is factorial. So what do you mean by factorial? So factorial is nothing but the product of first n natural numbers. Okay, so what are the natural numbers? N, we know n starts from the set 1, 2, 3, etc. Okay, to infinite times. Okay, suppose you take, see here, I said n consecutive. Consecutive means the very next number. Suppose I take 5 numbers, that is 1 to 5. 1 into, 2 into, 3 into, 4 into, 5. So how I can write this? This I can write in the form of 5 factorial. This is how I write factorial. So factorial is nothing but the first n consecutive natural numbers. Suppose I write 4 factorial. What does it mean? 4 factorial is nothing but 4 into 3 into 2 into 1. You have to multiply those. Okay. Similarly, 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay. And 1 factorial is 1. Okay. So it is generally assumed or it is generally agreed that 0 factorial is always 1. Okay. So why 0 factorial is always 1? I'll tell you in my next video, so keep watching it, okay? So, but we generally, all the mathematicians have agreed that 0 factorial, we can take it as 1, okay? So, next one. Now, we have permutation. So, what do you mean by permutations? So, permutations, as I said, it is nothing but arrangement of an object, okay? It is an arrangement of an object or any digits or any letters you can say. Okay, so here we have two types of permutation. One is permutation with repetition and permutation without repetition. So what do you mean by permutation with repetition and what do you mean by permutation without repetition? Let me see through an examples. Okay, so here, how many 3-digit numbers can be formed using first 5 natural numbers? What are my first 5 natural numbers? That is 1, 2, 3, 4, 5. So these are my first 5 natural numbers. How many digits of numbers we have to write? We have to form 3 digits of numbers. So 3 digits means we have units place, tens place and 100 place. So using only these 5 numbers, that is 1, 2, 3, 4, 5. You have to form a, how many digits? 3-digit number. So let me start from 100. Okay, the smallest, so I cannot take 100 because it contains 0 and 0. So let me take it from what? 1, 1, 1. So 1, 1, 1. Next is 1, 1, 2. Till how many it will be the maximum number? That is 5, 5, 5. We may have numbers like 2, 3, 4. We may have numbers like 4, 1, 5. We may have numbers like 3, 2, 5 like this. Okay. So like this, we can put any number in the place of units, any number in the place of tens, any number in the place of hundreds. Okay. So all 5 numbers can be filled in hundreds. So therefore, how many numbers we can fill? All the 5. That is 1, 2, 3, 4, 5. All the numbers can take or place of 100. So that's why it is 5. Okay. What about tens place? Tens place also, any number from 1 to 5 can be taken. Okay. That is, see here, the digits are repeated here. Okay. 1, 1, 1, 1, 1, 2, 5, 5, 5 we have. Okay, so here the digits are not repeated, but we have a numbers where the digits are repeating. So therefore, any number from 1 to 5 also can take the place value of 10. That is 5 numbers can take. In the place of unit also, it is similar. Okay, so how many arrangement? As I said, they are occurring simultaneously. So therefore, here we are using the product rule. Okay, so what does product rule says? So that is 5 into 5 into 5. Okay, so that is totally how many ways we can perform here? That is 125 ways. We say it as ways. Okay, so let me once again tell you that how many 3 digits number can be performed using first 5 digits. We have a first 5 digits, that is 1, 2, 3, 4, 5. 3 digits number mean it has units place, tens place and 100 place. All the numbers from 1 to 5 can take hundreds place also. All the numbers from 1 to 5 can take tens place also. All the numbers from 1 to 5 can be used in units place also. So, okay. So, there are 5 possibilities in 100 place, 5 possibility in tens place and 5 possibility in units place. So, therefore, the total number of permutation or the total number of ways of arranging these numbers is 5 into 5 into 5. That is 125 ways. Okay. So, next one. In how many ways 3 books can be replaced next to each other on a shelf? We have a shelf. Let me think. We have a shelf. We have 3 books. Okay. So, one is Kannada, English, Maths. Okay. So, we have 3 places in a shelf. Suppose I arranged Kannada in any of the three places. Let me fill in the middle place. Okay. Can I arrange English in the same place? No, because the place is already taken by Kannada book. Okay. So therefore, I can arrange in any two places. So that is English. Okay. So the only option for the maths is the last one or the last place. Okay. Here, I cannot put all Kannada, English and maths in the same place. Okay, so the place is already taken by Kannada and the place is already taken by the English textbook. So therefore, the only place left for maths is the only one. So how I write this in numerical form? So we have three places here. Okay, so suppose the first place, if I take first place, any three of the books can be filled. Any three of the books can be filled. So I have three chances there. Okay. If one book is filled, I have left with only two books that I can fill in either the last one or the middle one. So therefore, there is only chances left in this place is 2. Okay. And the remaining one is 1. Okay. So here I cannot repeat the objects. Okay. Because the place is already taken by the object. So therefore, my total number of permutations here is 3 into 2 into 1. Okay. So therefore, it is how many ways? 6 ways. Okay. So we can arrange the books in a shelf in 6 ways. Okay. Got it. So this is what the difference between the previous one and this one. Okay. So here you can see that any place can be taken by any objects from 1 to 5. Okay. Because the digits are repeating in hundreds, tens and unit place. Whereas here, it cannot be repeated. Once the place is taken by one object, so the other places have to be filled by the remaining object. So we cannot repeat the digits or objects or letters here. Okay. So therefore, this is an example for without repetition. So permutation without repetition, and this is an example for permutation with repetition. Okay, so I think you have understood what do you mean by repetition and without repetition. Okay, so next we'll go for the concepts in general. In general, how we can write the number of permutations with repetition and without repetition. Okay, suppose you have n elements. Okay, and you have to place in R. You have R number of places. I don't know, so I'll consider R number of places. How many times you can fill n in R number of places? Okay, so in all R number of places you can write n, n, n. Similarly to the last one you can write n. So how many times? R number of times. Okay, so therefore the number of permutations of n elements is n power R. So this is the thing you can see here. As I have given the example of 5 into 5 into 5. So how many places we had there? We have to form 3-digit number. That is, we had 3 places, 3 chances to fill 5 numbers. Okay. So therefore, 5 numbers can be placed in 3 arrangements. So therefore, there 5 cube I can take. That is 5 into 5 into 5 is nothing but 5 cube. Similarly, if you have n elements and R number of places, you can write this as n power R. Okay. So similar, next one. The number of permutations of n elements without repetition is n factorial. Okay. So that one you can take an example of arranging the books in a shelf. So you had 3 places and 3 numbers. So how many arrangement? That is 3 into 2 into 1 we had take. So what is 3 into 2 into 1 in terms of factorial? That is 3 factorial. Correct. Similarly, if you have n objects in n number of places without repetition, then you can write this as n factorial. Okay. There the elements are not repeated. Okay. So therefore, it can write in the form of n factorial. So this is the simple formula you can use while using the problems. Okay. So the one more thing, we'll start solving the problems on it. So we have a keywords for permutations, like when they're not directly problems like statement problems. For permutation, they'll choose how many ways we can arrange, how many ways, ordered ways we can arrange, okay, how many unique ways we can arrange. So these sentences are used for permutations. Whereas for the combination, the keywords are pick, choose, select, combinations. So these are the words they formally use in statement problems. So by choosing the keywords only, you can understand whether I have to do the permutations or combinations. Okay, if nothing keyword is given, so you have to analyze the statement properly. You have to visualize it and then solve the problems in kind of statement problems. Okay, so for permutation, they actually use like arrange, ordered way, unique way. So these keywords for permutation, and for combination, we can say select, choose, pick, combination also used. Okay, so next. So this is a formula for the permutation. N number of elements in R number of places. Okay, so that is N objects can be arranged in R number of places. We can take it as N factorial divided by N minus R factorial. So the proof is not here. So just learn the formula NPR. So N, okay, and R. So N number of objects, R how many objects or places we choose. Okay, so therefore N factorial, you know I have said N factorial is nothing but N into N minus 1, N into N minus 1 into N minus 2, the last term is 1. Okay, for example, 7 factorial I said. So 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1. So multiply all the numbers from 1 to 7, you will get 7 factorial. Okay, so we'll take few problems, very simple problems on permutations. Okay, the first one. So find the values of 10p2, 8p6. So we have here 10p2 and 8p6. So let me take the first problem. Okay, so that is 10p2. What is the formula for permutation? That is NPR is equal to N factorial divided by N minus R factorial. So what is the value of N here? Clearly it is 10. What is the value of R? That is 2. Okay, so what do you mean by N factorial? 10 factorial. That is, you have to multiply all the numbers from 10 to 1. Then 10 minus 2 factorial. Okay, so 10 minus 2 factorial is nothing but what? 8 factorial. So here I'll give you the hint, that is you have to write like 10 into 9 into 8 into like the numbers till 2 into 1. Okay, so divided by 8 into 7 into, so till the numbers 2 into 1. So what we usually do? We usually cancel. Okay, then I'll write 10 nines are 90. So this is the value for this. Okay, one simple concept for this is you have to arrange 10p2. Okay, so what I'll do is we have 10p2. So see here, this 2 represents, write only the 2 numbers from 10. So that is 10 into 9. So what is this? 90. Okay, this is a simple thing you can use. Either you can do writing all the steps or using this simple concept. Okay, so you can just write the 2 factors. This you can take it as a factors. You can take this as how many factors I can write. So 10p2 means only write 2 factors, that is 10 into 9, you will get 90. Or you can use this method also using the formula, that is n factorial by n minus or factorial. Write all the factors from 10 to 1, write all the factors from 8 to 1, cancel the numerator and denominator terms, then multiply it, you will get the same, that is 10 nines are 90. Okay, so similarly, so 8p6, as I said, use this concept, it is very simple. 8p6, so what do you mean by 8p6? Just choose only what? What you have to write. So 8p6 means 8 factorial divided by 8 minus 6 factorial. Either in this way you can do. So therefore, you will get all the numbers from 8, 7 till 1 all divided by 8 minus 6 means 2 factorial, that is 2 into 1. So 2 into 1, 2 into 1 get cancelled. So you will be having the numbers from 8, 7, 6, 5, 4, 3, 2. So 2 has cancelled. So simply you can write this as 8P6 can be written as 8 into. So write the 6 factors from 8. 8, 7, 5, 4, 3. So multiplying all those numbers, 8 into 7 into 6 into 5 into 4 into 3. So multiplying all those number, you will get the value for 8P6. Okay. So this is how we will calculate for 10P2 or 8P6. Any numbers can be calculated when N and R is given. Okay. So either you can do all the steps or you can choose how many factors I can write, just multiply it. Okay. For example, suppose you have 7P3. Okay. So what does this 3 represents? Just write the 3 factors from 7. Okay. So that is 7, 6 into 5. So this is the answer. Okay. 7 into 6 into 5. So this is the answer for 7P3. So similarly, you can calculate when N and R is given. Okay. So let me take the second problem, that is find N if NP3 is 210. So here I have to find the value of N. So the value of NP3 is given, that is 210. I don't know what is the value of N. So let me write it. We know this NP3 is equal to 210. So what, use a formula of permutation, that is N factorial by N minus R factorial. So how I can write this? N factorial divided by N minus 3 factorial. So that is 210. Okay. So what is the expansion of N factorial? N factorial can be written as N into N minus 1 into N minus 2 into N minus 3. I'll stop here. So factorial I'll use. Okay. Factorial whole divided by N minus 3 factorial. That is equal to 210. Okay. So we can clearly cancel all the terms, that is N minus 3 factorial terms. So what is remaining now? That is N, N minus 1, N minus 2. That is equal to 210. Okay. So now by inspection, I should find what is the value of N. Okay, by inspection method or by just calculating 210. You can use this method also. So 7, 3s are 0, 6, 5s are. Okay, suppose if you take 7 as N, the largest number as N. So you can write this as 7 into 7 minus 1 into 7 minus 2. That is equal to 210. So you can clearly say N is equal to 7. So therefore, my value of N is 7. Okay. So see here what NP3 is given. Use the formula N factorial divided by N minus 3 factorial. So which I can write it as N into N minus 1, N minus 2, N minus 3 factorial over N minus 3 factorial. So we can cancel all the terms till N minus 3 factorial. So the remaining terms are N minus 1 and N minus 2. So using simple calculation, we can just, or by using inspection method also, we can write N as a 7. So 7 minus 1 is nothing but 6. 7 minus 2 is nothing but 5. So when you multiply, you will get 210. So when I write in this expanded form, this takes the form of 7, 7 minus 1, 7 minus 2. So therefore, my value for N is 7. Next problem will take, if NP3 and NP2 is 3:1, find N. Okay, so what is NP3 is to NP2? Any ratios can be written in terms of fractions. For example, if you have A is to B, then you can write this as in the form of A by B. Okay, so the same concept I'll use here. NP3 is to NP2 is equal to 3 is to 1. So this first portion, I'll write this as NP3 over NP2. That is equal to 3 by 1. So how NP3 can be written? NP3 can be written, or just write the first 3 factors of n, that is n minus 1, n minus 2. I have written the first 3 factors in the factorial of n. So similarly, here we have 2. So choose only 2 factors, that is n and n minus 1. So this is equal to 3. Okay, cancel the terms n, n minus 1, n minus 1. So I have left with n minus 2 is equal to 3. So when you shift minus 2 that side, it will become plus 2. So therefore, what is the value of n? The value of n is 5. So n is equal to 5. That is 3 plus 2 is 5. Very simple problem. So next one. If 5PR is equal to 60, find the value of R. So use the same concept here. So we have 5PR is equal to 60. Okay, so 5 factorial divided by 5 minus R factorial, that is equal to 60. Okay, so how 60 can be written? So here also we can use the concept, very simple concept, that is 60. So that is by inspection only we can assume. So 5 ones are 5, 5 2s are 10. Correct? Okay, so next 4 3s are 12. So we can say 5 4 into 3 will gives to 60. So this can be written as 5 into 4 into 3. Okay, so just convert this in this form. Okay, so that is 5 factorial divided by 5 minus R factorial. So you are just writing the 3 terms of 5 factorial, that is 5 4 3. So therefore I can write this as in this form, 5 factorial divided by 5 minus 3 factorial. Okay, as I said, so when you have written 3 numbers, that is nothing but 3 factors you can write in the 5 factorial. So therefore 5 minus 3 factorial. So when you compare these 2 equations, you can clearly say that is R is equal to 3. Okay, so this is only by inspection method. Okay, so once again, so we have 5PR is equal to 60. So this can be written as 5 factorial by 5 minus R factorial. So 60 can be taken as 5 into 4 into 3. So 5, 4, 3, 2, 1, if you considered it as 5 factorial, and you are writing only the first 3 factors. So this, when you convert it into the formula of permutation, this will take like this, 5 factorial by 5 minus 3 factorial. So when you compare your left hand side and right hand side, you can clearly say that is 5 minus 3 factorial. So therefore your R is equal to 3 here. Next question. In how many ways 5 people can stand in a queue? Okay, so this is about the place. When we have 5 places, let me consider 5 places we have. 1, 2, 3, 4, 5. Okay, so let me take 5 persons, A, B, C, D, E. Okay, A, B, C, D, E. A can take any number of places. Okay, he can choose any place. Okay, once the place A has taken, there are only 4 places left. Okay, so we cannot put A again in some other position. Okay, so there are only 4 possible places and 4 remaining people. Suppose B has taken some other place, then there are only 3 possible places where 3 different people can stand. Okay, suppose C has taken here, D has taken here, E has taken here. So here we can clearly say, here the people cannot repeat in different places. So this is an example for permutation without repetition. So how many people you have? 5 people. And how many places? 5 places. Obviously 5 people can stand in 5 different places in a queue. Okay. So we have clearly understood when the permutation is not repeated, when you have n number of things, then permutation is n factorial. So therefore, your answer for this answer is 5 factorial, because 5 people can be arranged in 5 different ways. So therefore, this is 5 factorial. Okay, so that is 120 ways you can say. 120 ways. As we have learned, permutation without repetition, that is n number of objects arranged in n different ways, that is n factorial. So here you have 5 people, they can arranged in 5 different places. So therefore 5 factorial is the answer, that is 120. So your total number of permutation for this answer is 120. In how many ways 5 letters can be posted and 5 letter boxes if each boxes has 1 letter? So let me take, we have 5 boxes here. Okay, so we have 5 different letters. Okay, if one letter has been put to the second box, then we are left with only 4 letters. So we cannot put the same letter on the same box. Okay, so they have said you if each box has 1 letter. So if the second box have used to put for 1 letter, then we are left with only 4 letters. That 4 letters we can use any other 4 boxes. So here also the objects are not repeating. When the objects are not repeating, our permutation is n factorial. So here we have 5 letters where they are not repeating. So therefore, total number of ways for this also. So my total number of ways of this also 5 factorial, that is 120 we can say. Okay, so we have used 1 letter box for 1 letter, then we are left with only 4 letters with 4 different boxes. So that's why my answer for this question is 5 factorial. Next one, how many 3 letters words can be formed using only consonants? How many consonants we have? We have 21 consonants. So but each only once. Okay, so we have to arrange 3 letters word. We have to form 3 letters words. So 3 letter words means we have 3 places. So they are telling that if one consonant is used in one different place, they are not used in other. That means they are not repeating. Okay, so they are not repeating. So we have number of consonants 21. So how many letters we have to choose? We have to choose 3 letters. So we know that 21 factorial. N factorial is nothing but 21 factorial. But how many arrangements of letters? Only 3 letters. So therefore, you have to choose only 3 factors of 21 factorial. That is 21 into 20 into 19, which is 7,980. So either you can use this form also, or you can use the formula also. So how many consonants we have? 21. How many consonants we have to choose? That is only 3. So 21 P3. So how we will write 21 P3? Write only the first 3 factors from 21. So that is 21 into 20 into 19. So that is equal to 7,980. So let me take the next question, that is 8th one. How many different signals can be made by taking 3 different colored flags at a time from 7 different colored flags? So you have to choose 3 different colored flags out of 7 different colored flags. Okay, so this can be formalized in the permutation as 7P3, because you have to choose only 3 colored flags out of 7 colored flags and you have to arrange it. So therefore 7P3, how I can write 7P3? Since you have to choose only 3 flags, just write the factors, only 3 factors, that is 7 into 6 into 5. Okay, so 7 into 6 into 5. So how many ways you can arrange those flags? 210 ways. So 210 ways. Okay, so next question. How many different arrangements can be made with the letters of the word Monday? Okay, so we have a word Monday. How many letters we have? We have 1, 2, 3, 4, 5, 6. 6 letters. So we have to arrange this. Okay, so without meaning or without meaningless, we have to arrange all the 6 letters. So that means we have 6 places. So therefore my answer is 6 factorial. So we have different 6 letters, okay, that we have to arrange. So therefore my number of ways or number of permutation for the word in the letters word in Monday is 6 factorial. Next, so there are 4 routes from A to B and 3 routes from B to C. In how many ways can you go from A to C via B? Okay, so from A to B, how many ways we have? So this is A, B, C. So there are 3 different places. A, B, C are 3 different places. How many routes we have from A to B? We have 4 different routes. And from B to C we have 3 different routes. So how many ways you can choose to go from A to C? How many you can choose? See, suppose you go from this way. Next you can choose either this way or this one or this one. Suppose you went through this way, then you can choose any of the 3 again. Suppose you choose this one, then again any of the 3. Suppose you choose this one, then again any of the 3. So you have 4 possibilities from A to B and 3 possibilities from B to C. Okay, so using FPC. Okay, what is FPC? My fundamental principle of counting. Okay, so what does it say? It's, okay, when n different operations are performed simultaneously along with n different operation, then the total number of permutations can be written in m into n ways. So what happens here? So therefore here total number of ways. Total number of ways here is 4 into 3. So that is 12 ways. Okay, so this is my answer. So we can choose any routes through B from A to C. Okay, so this is all about, we have learned what is permutation, combination. So what is the difference between permutation, combination? So we have learned the fundamental principle of counting, both sum rule and product rule. Then we have seen what do you mean by factorial and how we will write the factorial of different numbers. So we have learned the formula of permutation and very simple problems using the formula. Okay, so this is all about today's session. So keep watching and keep learning. So therefore, we'll meet you in the next session. Thank you.